This factor is the third one, which is going to change the equilibrium mixture, and this is the effect of the temperature. Again, this is the one of the reaction is given, formation of ammonia, and there are the two ways to express the change in heat, because this reaction is the exothermic reaction because the energy is released, and maybe you can write separately change in enthalpy is equal to minus 92.2 kilojoule, or there is another option, you can write this change in enthalpy along with the reaction, and because this is the releasing, that's why this is written on the product side. So if you write along with the reaction, then it would be better to understand the effect of the temperature. So because the temperature is involved, so you must know that whether the reaction is the exothermic or the endothermic, because the change in temperature is going to influence differently on the reaction if it is the exothermic or the endothermic. So this is the reaction, exothermic reaction, energy is released. And now what is the effect of the temperature? This is shown by a simple graph. So let's suppose it is starting from the temperature 300, the values are given over here. When the temperature is 300 Kelvin, the value is this. And when you are increasing the temperature along the x-axis, there is decrease in the equilibrium constant. That means the concentration of the ammonia is going to decrease with respect to the temperature, and this is, because this is the product divided by the reactant, the ammonia concentration is decreasing, and the concentration of the nitrogen and hydrogen are increasing with the increase in the temperature. That's why the value of the Kc is decreasing. So why this is happening, and this is again you can explain with the Le Chatelier principle, because here this reaction is the exothermic reaction and the energy is on the product side, and when you increase the temperature, there should be more stress on the product side and the reaction proceed towards the backward direction. And when it proceed to the backward direction, that means with the increase in the temperature, there is the decrease in the concentration or the pressure of the ammonia, and simultaneously there is increase in the concentration or the pressure of the nitrogen and the hydrogen, and the equilibrium constant is decreased. And in the other way, this is the other example, and this is the endothermic reaction, because this is a change in enthalpy is having the positive sign. That means energy is required or the temperature is required for this reaction to proceed towards the forward direction. So that means this, again, there are the two ways to write the change in enthalpy. One is you can write it separately as given over here, or you can write along with the reaction, so you can easily understand the effect of the temperature. So here, because the energy is required, so you can put the energy on the reactant side. So you can explain with the same effect when you increase the temperature. So that means there is more stress on the reactant side. So the reaction will proceed towards the forward direction. And with the increase in the temperature, there will be increase in the concentration or the pressure of the NO2. And there is decrease in the concentration and the pressure of the N2O4. And this is displayed with the example. Let's suppose at this start, at low temperature, you can see the color. And when it is the light brown, and when you increase the temperature, it is converted in the dark brown because NO2 is in brown color and N2O4 is in colorless. So that means by increasing the temperature, the reaction proceeds towards the forward direction. And this is the effect of the temperature on the reaction. And in conclusion, what we have discussed over here, there are the two reactions. One are the exothermic reaction and the endothermic reaction. Actually, the effect of the temperature depends on the sign of the delta H. So equilibrium constant for an exothermic reaction means having the negative value decreases as the temperature increases. And in the second example, we have discussed the equilibrium constant for the endothermic reaction, which is having the positive value increases as the temperature increases. So this is the effect of the temperature, and a few examples are given over here. So these are the examples. First is the again, this is the reaction. You can explain the reaction by with the change in enthalpy. And look at the value. The change in enthalpy over here is the